All right, so today we're going to finish up Chapter 6, Section 3, and we're still talking unit circle. We're also going to be using our calculators. So if you have your calculators, you can get them out, because the first examples that we're going to do are going to be calculator questions. Now, again, what we need to do is remember the ratios that you would use to find, say, sine, cosecant, cosine, secant, tangent. Because they're going to give you the ratio, you have to figure out which angle goes with it. So again, we'll be using our unit circle, but at the beginning we're going to do calculator questions. Now, in the homework tonight, you're going to get questions like this. However, they're not going to be on the unit circle. So the reason why I circled number 6, I believe it's the first question. You're going to need to remember when the measurement that's given to you, the angle, degree, and radians, is not on the unit circle. Remember, this is where you're going to add 2 pi to get it onto the unit circle. So that's what you would do if it's negative. Or if it's a really large angle, you have to subtract 2 pi. So the first 3 questions in the homework are going to be like this slide that we did the other day. You're adding and subtracting 2 pi to get it to a radian measure that's on your unit circle. And then you would find the answer. No calculator questions like this tonight. Now, this is the new stuff. Now, when we did this in the Brown book, what we did was, in order to find the 2 angles that were the answers, remember, we did it on our calculator. We found the measurement for quadrant 1. That was our reference angle. Then when we did it in the Brown book in quadrant 2, remember we did 180 minus the reference angle. What we're going to do now, since we're in radians, instead of 180, we're going to use 3.14. Because what we should be doing here is pi times the reference angle. But instead, we're just going to use 3.14, subtract the angle we get from quadrant 1. Then in quadrant 3, we're going to take 314 and add the reference angle. Remember, in the Brown book, we did 180 plus the reference angle. But now we're using pi, so 314 plus reference angle. Then for quadrant 4, remember we did 360 minus the reference angle in the Brown book. Now what we're going to do is, remember, pi approximation is 314. If you times it by 2, which is equivalent to 2 pi, which is 360, you get 6.28. So this is why we're doing 6.28 minus the reference angle. So this is how we're going to get the other angle, or the other, and maybe 2, because once we find the reference angle. So let's go ahead and take a look at the calculator. So notice the instructions say, using your calculator, we're only going to be looking for angles on the unit circle. So we're looking for radian measures that are in between 0 and 2 pi. Notice the parentheses around 2 pi. If you were to get 2 pi as an answer, you would not list it, because 2 pi has a parentheses that's only the cutoff. Remember, in radians, this would be from 0 to 6. So what we're going to do first, we're using inverse trig when we look for angle measures. This time, S, instead of theta, here, they're calling it S. So we're looking for an angle measure. So to do this, I'm going to do cosine -1. So you're going to hit your shift key or second, put the decimal, hit enter. We're going to round to the hundreds place. So 0.25. Now let's figure out which quadrants cosine is positive. All students take calculus. Cosine is positive here and here. On the previous slide, the rule said to take 6.28, subtract your reference angle, and that will give us the measure for quadrant 4. Once I do this subtraction, I end up getting 6.03. So the 2 answers here for S is 0.25, comma, 6.03. Let's try the next one. Again, I'm still looking for an angle measure. It's the same one. So all students take calculus. My answers are going to come from 1 and 4. So to get angle from quadrant 1, cosine -1, 0.7826. Hit enter, and you get 0.67. That's the measure for quadrant 1. It's 2/3 of a radian, which is in quadrant 1. Then to find the angle measure in quadrant 4, I'm going to take 6.28, subtract 0.67, and I get 5.61. So the two answers here for S is going to be 0.67, 2/3 of a radian, and a little bit more than 5.5 radians, which is quadrant 4. Now the next one is cotangent. Yes?
So normally when we do the inverse of the trig function, we're talking about angle measures. Are these angle measures?
Yes.
Okay.
And they're in radians.
Okay.
So again, if you think about it, remember on your in your quadrants, 1 radian is about here, and it's about 57 degrees.
So we technically should have the degree sign in our answer?
No, these are radians, they're not degrees. Okay, so this is 1 radian, which is equivalent to 57 degrees. So when it's a radian, you don't put the degree symbol. You would actually write radians afterwards.
So the radian is just the line?
A radian is a measure. So if I were to take 57 and I were to multiply it, I could convert it into terms of pi into radians. There are almost 6 radians in a full circle, because 2 radians is about 114 degrees. So this is where 2 would be located. And then if I did 57 times 3, that's going to give me about 171. So 3 radians is located about here. And then 4 radians here, 5 is here, and 6 is a little bit less than the full circle.
So right now, the 5.61 would be in the 4th quadrant?
Correct.
Okay, gotcha.
So all of these are in radians. You do not put the degree symbol when something's given to you in radians. Everybody good? All right, now, the next one, number 18, notice there's no COT button on your calculator. This is where we need to know the reciprocal. So remember that tangent is the reciprocal to cotangent. So when I go to do this on my calculator, I'm going to do tangent -1 and then 1 over 0.2994. And then once I hit enter here, I'm going to get, for my first quadrant, all students take calculus, tangent positive here and here. Once I hit enter here, I get 1.28. So that's my 1 radian. So like 1 1/4 radians is in quadrant 1. Quadrant 3, remember you're going to take 314 and you're going to add that reference angle. Once I add these, I get 4.42. So almost 4.5 radians, which is located in quadrant 3. So the two answers, 1.28, 4.42. Yes?
Is there a maximum that your reference angle can be?
Well, you figure it's got to be less than maybe 1.5, because if you figure 2 radians is here, this 90 degrees, if you want to stay in quadrant 1, it's probably got to be under, say, 1.5 radians. As long as you put the answer in that's given to you as positive, you're going to get a quadrant 1 reference angle. Let's try number 19. Again, it's a reciprocal. Cosecant is the reciprocal to sine. So I'm going to do sine -1, 1 over, and get rid of this decimal point. Make this 1.0219. There's 2 decimal points there. So 1.0219, hit enter, and I get 1.36. So that's my quadrant 1. 2, 3, 4. All students take calculus. I want to know where sine is positive, and it's positive here in quadrant 2 and 1. So I'm going to do 314 minus the 1.36, and I get 1.78. So the 2 answers for S, 1.36, comma, 1.78. Yes?
For like the sine, cosine, tangent, how do you know if you need to put a -1?
We're looking for angles, so we're always using the inverse.
Okay.
If we're not looking for an angle, then you just put the button, the sine, cosine, or tangent button. But when you look for the angle, we always do inverse. All right, next one. Remember back from the Brown book, I told you in order to get the reference angle in quadrant 1, we need to enter this as a positive value. If you don't, you're not going to get a reference angle from quadrant 1. So the way I'm going to enter this in my calculator is sine -1 point positive 3425. This is going to give me 0.35. This is a reference angle in quadrant 1. It's like 1/3 of a radian. Now I need to figure out where sine is negative. All students take calculus. I'm looking for angles from quadrants 3 and 4. The reference angle is not one of my answers, but I needed to find it because to find the angle in quadrant 3, I need to do 314 plus 0.35, and I get 3.49. And for quadrant 4, 6.28 minus 0.35. And that is going to give me 5.93. So the 2 answers here are 3.49, comma, 5.93. Do not list the reference angle as one of the answers, but we needed to find it in order to calculate quadrants 3 and 4. So this is how you find angle measures using your calculator. Now we're going to find the angle measure using the unit circle. And this is what will be on the quiz on Monday. Everybody good? Let's go on. Now I went ahead and added a picture of a unit circle on my slide here so I can have a quick reference here. Now, remember back in the Brown book, I told you to memorize that the tangent of 45 equals 1. Because if you look at your unit circle, you don't see where tangent equals 1 here. So by memorizing that the tangent of 45 is 1, you're going to do your all students take calculus. I know that tangent's positive here and here. If your reference angle is the 45, which over here is the pi over 4, then in quadrant 4, it's going to have the one that's got the same denominator, and it's the 5 pi over 4. So the 2 answers here are going to be pi over 4 and 5 pi over 4. Now, we can do the same thing. We could add and subtract, but it's easier just to look to see where tangent equals 1. And it's the 45 reference angle. Let's try the next one. You're just knowing that for tangent, remember tangent is y over x. I'm looking at my order pairs. to see where y and x are the same, because when you divide the same thing by the same thing, you get 1. And that ordered pair was negative root 2 over negative root 2, which gives you positive 1. Same thing in quadrant 1. They're both positive. Let's try the next one. Now, if you recall from, I think, the second slide, remember cosine, we look at x. So what I'm going to do is I'm going to narrow down the quadrants to see where I have to look for. All students take calculus. I'm looking to find the quadrants where cosine is negative, which is going to be here and here. Now what I need to do is remember cosine is equal to x. So I'm going to look at the ordered pairs, and I'm going to look at the x of the ordered pair, and I'm going to look to see where x equals negative half. So I've narrowed it down to quadrants 2 and 3. So I come over here. I'm looking for x to equal 1/2. I can see it's right here. So my answer is 2 pi over 3. And in quadrant 3, it's over here. So it's 4 pi over 3. Notice both of my answers are going to have the same denominator. And that's what they were singing in that video. So the answer to this one, where x equals 1/2, s is going to equal 2 pi over 3 and 4 pi over 3. Oh my goodness, what happened here? Oh. There, okay. Everybody good? Let's try the next one. This one, remember sine, we're going to look at the y of the ordered pair, because remember sine of s is equal to y. Again, let's narrow down which quadrants we need to look in. All students take calculus. Sine is going to be negative in quadrant 3 and 4. So I'm going to look to see where y of the ordered pair is equal to negative 1/2. I'll go take a peek at my unit circle. And I can see that y is equal to negative 1/2 right here and right here. Notice they both have a denominator of 6. So my two answers here are going to be 7 pi over 6 and 11 pi over 6. Try cosine. Cosine of square root of 3 over 2. Remember cosine, we look at the x. So I'm going to look at the x. Let me narrow down my quadrants. All students take calculus. Cosine is going to be positive in quadrant 1 and in quadrant 4. So I'm going to look for x equal to root 3 over 2 in the ordered pairs. So let's go up to the unit circle. And then x is equal to root 3 over 2 right here at pi over 6 and at 11 pi over 6. And those are my two answers. And that's what s equals. Now, I'm going to add some information to this to help you understand maybe a tangent or a reciprocal. Because when it's sine and cosine, it's super easy. You're just looking at the ordered pairs that are there. But let's say instead they asked us to find cosine. Let me add a... All right, I've got a unit circle here. Let's say instead the question said find secant of s when it equals 2. Remember, secant is the reciprocal of cosine. So it's 1 over x. So I'm looking at the x, and then I'm going to flip it. So really what I'm looking here is to find out where it's 1/2. So here, if I look at my unit circle, I can see that it's going to be right here. And let me do my all students take calculus. And I'm looking for secant, which is the reciprocal of cosine, also here. So here, where I flip my x, the 1/2, if I flip it to its reciprocal, it turns into 2/1, which is what I was looking for. So the two answers here, when it's a reciprocal, you flip it. So it's going to be pi over 3 and 5 pi over 3 when it's a reciprocal. Now, when it's tangent that doesn't equal 1, let's say they give us the question, and let's say it says, find s when tangent equals √3. Looking at my unit circle, I don't see square root of 3 all by itself anywhere. Remember, tangent is y divided by x. So my advice to you is, because there's only 3 groupings of ordered pairs, divide them all ahead of time. And let me show you what I mean by that. So I'm going to do quadrant 1. I'm going to take the pi over 6, the pi over 4, and the pi over 3, and I'm going to find the tangent of all of those. So let me come down here. So if I do tangent of pi over 6, which is really 30 degrees, remember tangent is y over x. The order pair for 30 degrees is √3 over 2, comma 1/2. I'm going to divide it. Y divided by x. I'm going to change it to the reciprocal. I'm going to multiply. I'm going to cancel. And I get 1 over √3. I have to rationalize. √3 over 3. So the tangent of 30 degrees, or pi over 6, is equal to the square root of 3 over 3. My advice to you is, on your unit circle, maybe add to the outside edge here the tangent values. So for the 30 degrees, we're going to put √3 over 3. Remember, tangent of 45 is 1, because what we're doing here, let me go ahead and do it for you. Tangent of pi over 4, which is 45 degrees, we're really doing y over x, √2 over 2 divided by √2 over 2. Anything divided by itself is 1. So that's why I wrote a 1 there. Now let's do the tangent of the 60 degrees, which is the pi over 3. That order pair is 1/2, comma, √3 over 2. Y over x, so √3 over 2 divided by 1/2. So I'm going to flip it to the reciprocal. These cancel, and I'm left with the square root of 3. So now let me come up to my unit circle. I'm going to add √3 right next to the 60. Now, remember yesterday I showed you the similarities between the quadrants? Notice the order pair that's right across here is the same order pair. The only difference is, remember, the signs in quadrant 2 are negative positive. So this answer, when I do tangent, is just going to be same number, but it's negative, because you're dividing a positive y divided by a negative x. This one for the tangent of 135 is going to be -1. The tangent of 150, or 5 pi over 6, is going to be -√3 over 3. Now let's go down to the bottom 2 quadrants. Same order pairs, they're just in a different spot. So if you look at this one, this is -√3 over 2 and -1/2. It's the same as this one, and it's negative divided by a negative, which still gives you positive. And let me write it in red. And I'm still not in red. Okay, let me fix. There we go. √3 over 3. Tangent of 225, positive 1, because negative divided by a negative. And then the last one, root 3. Then if I come over here, I can put these same three numbers on this one. So here, the root 3 over 2, this one will be negative root 3 over 3, negative 1, negative square root 3. Now that I've saved the time of dividing y by x, now when you get a question, for example, let's say now I said, find tangent of s where it equals square root 3. You can again, let's make it negative root 3. I'm going to do my all students take calculus. I can see tangent is negative here and here. So now I'm going to come where I wrote it in red. And I can see that it's going to be 2 pi over 3. And also 5 pi over 3. And then I don't have to do the y divided by x. You might want to also add to your unit circle because you have open notes. Now, in the past, they had to memorize all of this. If you get this on an SAT, you're going to need to memorize all this. Okay? But you don't really need to memorize a whole lot. You can still divide it. But again, the more familiar you become with this, the easier the problems will be and you'll save time. Let's say the question instead said cotangent of s equals root 3. So this is where you'd have to go back and divide x by y, but really these are just going to switch places. But here, if I had to divide them, cotangent, you could just divide it and get the same answer. So let's say I wanted to do cotangent of 30, and that's going to be the answer. So so this is going to be 30. It's going to be pi over 3. Oops. Let me do the all students take calculus. Tangent's going to be positive here and here. So where cotangent x over y is going to be the 30 degrees because it's going to be root 3 over 2 divided by 1/2, which gives me root 3. So it's pi over 3, and then in quadrant 3, it's going to be 4 pi over 3. So if you wanted to add another one here and say, okay, these are going to be my cotangents, or just remember these two switch places. So whatever's going to help you, because I guarantee you on the quiz next week, it's not going to be sine or cosine. It's going to be reciprocals, and it's going to be tangent. And it's going to be angles that are not on the unit circle. You're going to have to find a coterminal angle by adding and subtracting 2 pi to get it there. And all your answers are going to be left in simplest radical form. If you give me answers as decimals, I know you used the calculator when you shouldn't have been. So it has to be in simplest radical form and in terms of pi. So that's it for the notes. Again, you don't have any of this in the WebAssign tonight. Let me also address the last 3 questions of WebAssign. They're going to be like, you can just flip them to the reciprocal and rationalize. But again, it might be beneficial if you do have all of the tangent values already divided to save time on your quiz. Questions you did the other night, for example, let's say I say find it gives you cosine of theta equals 8 over 17, and they're going to say find sine of theta. You're going to do it the same way you did it the other night. Remember, cosine is going to be x over r, so x equals 8, r equals 17. We need to find y by doing Pythagorean theorem. So the last 3 questions are the same thing. They're going to restrict you to which quadrant it's in, so just take that into consideration when you put your answer, if it's positive or negative. Yes?